Hello, my name is Rudrakant and I am part of our Client Services team. In this video, we would develop an understanding of the schema and administration of a cable duplexed SES server. So a cable duplex server. What is a cable duplex server? A cable duplex server, as the name suggests, is consisting of two things. One, a duplicated server. The first part is cabled. Duplicated server means that we have two servers. One is in active state, the other is in standby state. The duplication over each of the servers is carried out using a cable. Now, what is the active and a standby server? The active server is the one which takes care of all the call processing, how the calls have to be processed. The standby sits idle all this while, only to wait for the active to go down for any reason and then take over. Now, because the standby is not doing anything, not processing anything, and all the administration is carried out on the active server, how would our standby server remain up to date? For the standby to remain up to date, the data changes or any modifications which are made in the active server needs to be pushed into the standby server. So this is carried out using the cable. That is how the name cable duplicated SES. So this data replication from the active to standby is carried out using a RS-232 cable, which connects the serial ports between the servers. This cable is indicated over point number 1, the cable connecting the two servers using the pink wire. Cable number 2 is a crossover Ethernet cable which connects the SAMP between the two servers. The SAMP port of the servers get connected to the SAMP's internal Ethernet 2 interface. Cable number 3 that you are seeing is green color. At the intermediate level of both the servers, we see a cloud, which means that one end of the cable gets connected to the server, the other end gets connected to the customer network. This cable 3 is a straight through cable connecting the customer's server to the customer's network. This is actually the ETH0 of the server hardware. The fourth cable, which is in the blue color, is again a single cable and is a crossover Ethernet cable which connects both the servers' dual NIC ports, which is the ETH3 of the server hardware. You see 4 cables coming out of a single power supply which is named as 5. This is the power cord which is used to power up both our server and the SAMP cards. It is a general recommendation from Avaya not to have a single UPS connecting both the servers and their SAMP cards. In an event of any power fluctuation on the UPS, the entire SIP architecture would go down. The next slides speak pretty much the same which we have just discussed, so we are quickly going to move to the other slide. So once your SES is configured properly for a cable duplexed environment, you should see an output of the server something like this. However, how to do a proper administration for a cable duplex server? You should log on to Avaya support site and look out for the manual installation and administration guide for Avaya Aura SIP enablement services of the SIP version as per your requirement, the latest being SES 5.2.1. So in this output, you are going to see that SIP role is combined, which indicates that we are in a good state, everything is looking fine. There are no major or minor alarms in the system. The server hardware and the processes look okay. And the current server, which is server ABCD-1 on which we are running the command, is successfully able to see the other server, which is ABCD-2, and is able to determine the state of that server as well, which is in the in-service backup state. Now we have to configure the IPs of your server. So the IPs once configured should show something like this. ETH0 is the one which gets connected to your network. In my case, it is 172.xyz. Presence of ETH0.0 indicates that the server on which I have executed this command is my active server, and the IP which it is showing up is the virtual IP. ETH1 is the services port of the server. ETH2 is the one which gets connected to the SAMP card. ETH3 is again my corporate network. LO happens to be my loopback address. So when I execute the same command in my in-service backup or the standby server, I should see almost everything the same except the point of ETH0.0 because it indicates the active server. So let's see that. As you can see, when I executed the command of ifconfig on my ABCD-2 server, I didn't find the eth0.0 component in it. Rest all IPs remain the same. As you can see closely, the eth1, eth2 remains the same, whereas the eth3 varies, because eth1 continues to be my services port, eth2 continues to be the IP with which my SAM board gets connected. LO happens to be the loopback address, which would again remain the same. So, how to understand whether a SAMP card is properly configured or not? There's a command called SAMP diag -v. V is for verbose mode to get us detailed outputs. In this, we are going to see the hardware detail, which is the MAC ID, SAMP's own IP address, then host IP address, the SSH port for the SAMP, which is 10022, whether the SSH is okay, the HPI interface is working fine, and whether the SAMP overall is working fine. You should see consistent output in both the servers if you execute this command. I have provided you the output here for you to review the same. So now once the administration part is complete, both the servers have been able to communicate with each other. At that point of time, you would want to see the status of your application. How do you see the status of your application? The data sets, the SES database. It is done on a runtime basis using cat proc drbd. drbd gives you the runtime status of your database replication. This command would throw you the same output which would be seen from drbd-status. So let us look closely on the drbd-status output. I have provided the out taken out from two servers. First two lines speaks more around the version and the how it's been built, the release details. Let us concentrate on the third line. CS is the connection state, which states connected. It means that the server on which you are executing drbd status, in that server database is connected. ST stands for status, which says that primary/secondary. It means that the server on which you are executing this command is primary. The server to which this ABCD-1 gets connected to is the secondary server. ID states consistent, which means that the data replication has been going on successfully. When you see the output of the same command from the other server on the line 3, you are going to see connection state as connected, status as secondary versus primary, and ID as consistent. In a troubled system, you may find these entries a little different. We are going to see in our successive slides. So now once you are done with your drbd status, let us go into the check config command. This command is a standard utility out of SES or via SES, in which it looks into the configuration of the SES, whether it is configured correctly or not, or whether it is seeing any trouble. So once you hit your check config command, it is first able to identify that this is a redundant server. This server setup is a paired server. Now it starts to ping all the IPs that you have configured. As you can see, ABCD-1 and ABCD-2, both its HA address, which is the Ethernet IPs, along with the network IDs. Based on the pinging output, you get success or fail. It also looks into the DNS configuration. So if you do not have a DNS configured, this test would fail. You should not get alarmed because you have not configured your DNS. But yes, if you have configured your DNS and still it is showing as a fail, then we should be in a alarmed out situation. So this command further looks into your SAM board version. It also logs in to the other server's SAM board and sees whether it is able to log in or not. Thereafter, it looks into its own SAM board, looks into all of its 4 interfaces, and based on the results of all the execution of commands, it provides us the summary of number of tests which were executed, out of which the number of tests passed. In our case, it says that info for, I'm highlighting that, remote SAMP maintenance board ABCD-2, the login to this SAM board, login attempt to this SAM board had failed. So we have to verify what is happening here. So it's one of the troubleshooting steps that we have to carry out. So if such a situation arrives in front of you, you are going to typically see the first set of server alarms in your system, which says that cannot communicate with the remote system management card, as you can see here. This alarm will be a SES 23 major alarm, and we have to verify whether everything is properly connected or not. In my case, when I got this ticket, when I found this issue, I found that the crossover Ethernet, which was the cable number 2, was not properly connected. A similar SES23 can also be coming for another reason, with a description of the alarm as DRBD not in the connected state. In such a situation, you are expected to go and look into the RS232 cable, whether it is properly connected or not. If possible, have it replaced and verify if the alarm is still coming up. So when you have configured everything properly as per the documentation, you have verified everything as we have discussed in all the previous 11 slides, everything looks to be fine to you, and you are still facing issues with your cable duplex SES, you can reach out to Avaya and escalate SR to us. A few details which would be very encouraging from you to provide to us would be the output of etc host, samp diag-verbose, var log messages, server, SW version, alarm display, proc DRBD, if possible photograph of the back plane from both the servers so as to identify how the cables are connected. With these details, you can log a ticket with Avaya. It will help us do an initial analysis, and thereafter, based on the inputs and reviews, we can initiate the troubleshooting and request for further more detailed inputs from you. Thank you for your time and watching this video. We hope that this information was helpful. We welcome your comments, questions and feedback at mentor@avaya.com or on Twitter @avayamentor.